Hi students, in the previous video we discussed about acceleration due to gravity and what is the variation in g, acceleration due to gravity with respect to height or altitude. Now in this video we are going to see what is the acceleration due to gravity or what is the effect of depth on acceleration due to gravity. Okay, for that variation of g with depth. Now for this we consider Earth to be a homogeneous sphere. A homogeneous sphere means a sphere having uniform mass and properties throughout the surface. Okay, and let O be the center of the Earth and R its radius and capital M mass of the Earth. Let an object be placed at point A on the surface of the Earth. So like the previous derivation, that is effect of height or altitude, what we do is we find out what is the acceleration due to gravity on the surface of the Earth. Then in this case we also formulate an equation for acceleration due to gravity at a particular depth from the surface of the Earth, and then we find out the relation. So in this case Earth is considered to be a homogeneous sphere, which means having uniform properties throughout, of mass capital M, radius R. The acceleration due to gravity at point A on the surface of the Earth is given by G is equal to Gm divided by R square. Now what we are going to do here is we are going to convert M, mass, in terms of volume and density of the Earth. So we know the equation: density is equal to mass by volume, or mass is equal to density into volume. So in our case mass M is equal to density is denoted by rho and volume is 4/3 pi R cube. So we are going to substitute the value of M in equation. G is equal to Gm by R square. So we get G is equal to G, instead of M we substitute 4/3 pi R cube rho divided by R square, and this will get cancelled. So we get is equal to 4/3 G pi R rho. This is equation 1. Now what is the next step? Next step is to consider a sphere which is at a depth d from the surface of the Earth. Okay. Now this sphere is at a depth d from the surface of the Earth, and an object is considered to be at point P on the sphere. Okay. Now what is the distance from the center of the Earth to point D? Is actually r minus d. So acceleration due to gravity at point D is acceleration due to gravity at point B. Now, where is point B? At a depth D from surface of Earth is given by GD is equal to G M dash divided by, now what is the distance from center of the Earth? It is R minus D the whole square. In the same way as the previous, we are going to convert the mass in terms of volume and density. So, we can write mass M dash is equal to density rho into volume. Now, in our case, the volume becomes 4 by 3 pi into R minus D cube. Therefore, the above equation becomes GD is equal to G rho 4 by 3 pi R minus D cube divided by R minus D square. When cancelled, you will get GD is equal to G 4 by 3 pi R minus D into rho. This is equation 2. Now, what is our next step? We are going to divide equation 2 with equation 1. So, we get equation 2 by 1 gives GD by G is equal to G 4 by 3 pi R minus D into rho divided by G 4 by 3 pi R. The common terms will get cancelled. We will get this equation is equal to R minus D by R, which is equal to 1 minus D divided by R. Therefore, we can write GD by G is equal to 1 minus D by R, or GD, that is acceleration due to gravity at a depth D, is equal to G into 1 minus D by R. From this, we can say what? We can say that value of G at a depth is less than that on the surface. This acceleration due to gravity at a depth is less than that on the surface of the Earth. This is the reason why the value of G is less at mines than on the surface or on the plains. Next, we are going to see what is the weight of an object at the center of Earth. Now, actually, what is weight? It is the measure of gravitational pull of Earth on an object. So, weight can be defined as the gravitational pull or gravitational force with which an object is attracted towards the center of the Earth. It is given by W is equal to mg. So now we are going to see what is the weight experienced by a person if he is standing at the center of the earth. So acceleration due to gravity at a depth is given by GD is equal to 1 minus d by r. Now at the center of the earth, r is equal to d, or d is equal to r. So what happens to the above equation? The above equation becomes GD is equal to 1 minus r divided by r is equal to 0, which means the weight of an object at the center of the earth, W is equal to m, GD is equal to 0. So an object will experience zero weight at the center of earth, even if its mass is not 0. I hope this is clear to you. Thank you.